Now, to get data-driven insights in time, for you to take action in time, you need to take a systems approach to insight delivery. And that's really what operationalizing analytics is all about. Now, let's try to understand this concept, through a case study. So here, we are talking about one of our strategic customers with whom we have been engaged on the business analytics and information management space for a long time. And this customer is one of the largest specialty retailers specializing in travel retailing, operating across 11 different countries with more than 400 plus retail stores, catering to 200 million plus worldwide travelers, and showcasing and dealing with 700 plus super luxury brands that they offer through their stores. Now, this customer, being a luxury travel retailer, invests a lot of effort and time and money uh, on hosting very high-end events to engage with their most profitable, most uh, uh, valuable customers, to keep them engaged, to show some of their ultra luxury brands. And these events are hosted in seven-star properties with celebrity guests attending, and these are exclusive invites that go to only a very few set of customers who are the most valuable customers, most profitable customers, and the most loyal customers, to this organization that we work with. Now, the issue with them when we engaged on this topic was that their marketing team, uh, which was responsible to identify the customers to be invited, had a very manual process of going about the whole invitation for these events. So what they would do is they would manually extract customer data from the data warehousing landscape. They will sort it by loyalty tier and just take the first two loyalty tiers that they need to invite, and then they would just look at the most recent transactions done by some of these loyal customers in the top two tiers and just send them an invite. Now, this was in the quarter when we were engaged with them, this was the approach they followed. But this wasn't necessarily how they would do it every quarter. It would really depend on who is anchoring that process of identifying the list of invitees and what logic he or she is applying. So the whole process was very, very manual. It was very, very person dependent. It was effort intensive because extracting that data, massaging it, doing the filtering, finding out the list of invitees, etc. It would take roughly around 3 weeks of effort for two of the marketing analysts every quarter. And it was very inconsistent, slow, not scientific at all, because they were not sure if this is the right set of attendees they are inviting, or are they missing out on any high propensity customers who would have otherwise made a sale. So this was really the problem statement that was presented to us by this customer. What we did is, from a solution perspective, obviously, is that we implemented and we defined an advanced analytics based solution for them, leveraging our proprietary 4D methodology, where we took their customer base. We applied a technique called weighted RFM. RFNM stands for recency, frequency, monetary scoring. So we applied that rated RFM technique. We then clustered their customer into multiple segments using the weighted RFM technique. And once we had done the segmentation, we leveraged and did logistic regression for propensity modeling. And then through this advanced analytics algorithm, we were able to help them identify the list of customers that they should invite more scientifically. Now, as we did it on the base of 931,000 customers that they had, over and above what their marketing team identified manually, we could identify 278 additional must-send invitees that they had missed out through their process. Vimal, you can hear me?
I can hear you, Praveen.
Okay. So this is the solution we gave to them. Now, you would say this is a very typical run-of-the-mill advanced analytics solution. and what's really different about what we did. So let's talk about that. The first thing is, if had they gone to a specialist, so-called specialist advanced analytics partner, the way the whole engagement would work is this partner would ask them to get an extract of the customer data and all the data that's required. This partner will then run some black box algorithms in his or her own environment, feeding this data, doing certain black box analytics, and then coming back to them with a list of invitees they should invite. Now next quarter, when again there is a need to identify invitees, they'll again have to engage with this partner, give the data, and then he or she will again run the algorithm. Hey Vimal, can you hear me? So a specialist would deliver this solution by asking them for data, which this specialist organization will then take into its own environment, run some black box modeling in their own environment, and then come back, with a list of invitees that they should invite for their event. Now, next quarter, when again this customer of ours has to identify next set of invitees for the events in next quarter, they'll again have to engage with this specialist organization, go through the same process of giving the data, they're running some offline analysis and coming back again with a list of invitees. So this is typically how a typical advanced analytics engagement would run, and a specialist organization will work and engage. So while it will address the issue of the process being unscientific and inconsistent by using advanced analytics algorithm, etc., it would still not address the issue of this process being scalable, repeatable, and efficient, because there'll still be a need to extract their data, ship it to them, they running some algorithm, coming back with a paper deliverable that you'll have to then consume and then act on it. So this is what this is typically how advanced analytics engagement with advanced analytics partner would run, and that's really where we were different. So the way we did it was, right from day one, when we identified the problem statement, when we identified that this requires advanced analytics algorithm really to solve this problem, we also started to think how we are going to make it and make this an automated process. How do we leverage technology to deliver this as an ongoing online solution through the existing business intelligence landscape that our customer has, and make it a very repeatable self-service platform, which is what we did. So we implemented and embedded all of these algorithms that we applied to solve this problem into the existing data warehouse and BI landscape, and delivered it through a BI application on which their business users could continue to identify high propensity customers quarter and quarter on a very self-service basis. So that's how we delivered it differently. Let's look at what this solution constituted of and how we were able to operationalize it within the existing BI landscape. So step one, which is really about being able to identify the right set of variables, being able to profile the data that is required to do the problem solving, being able to identify the quality of data, what are the outliers, are there missing values, etc. We used MicroStrategy's Visual Insight tool itself. So MicroStrategy was their existing BI landscape, and they have a component called Visual Insights, which is used for exploratory data analysis. So we use the same Visual Insights tool to do the initial exploratory data analysis, to identify the outlier data elements, to do the variable identification, and to also identify the missing values and these key variables that we had to consume. So instead of trying to do exploratory data analysis and data profiling on an offline tool, we used their existing BI landscape and MicroStrategy's exploratory data analysis capabilities to do the initial data mapping and data exploration. Once we had done that, we knew that we have to do outlier treatment, and we have to also impute data for certain key variables where there is missing data. And for that we required obviously algorithms that will help us impute that missing data. For example, we identified that more than 47% of their customers were missing the age group variable, and therefore we had to write an algorithm that will help us impute the age group of a certain customer based on the transaction that customer is doing. For example, if they're buying more electronics or a certain kind of products, we can impute with a lot of confidence that what typically would be the age group of this customer. So we use certain predictive modeling algorithms to do missing value imputation. Now, some of these algorithms can be very, very uh, uh, heavy on processing capacity that they need, and therefore we implemented these algorithms on Netezza, which was the data warehouse landscape, to leverage the power of the massively parallel processing capabilities that Netezza offers, and all the database and data warehouse CPU cycles that were available to us. So all these heavy lifting data plumbing operations we embedded within their Netezza framework. Netezza has a native out-of-box connective integration with R, and therefore we wrote all the algorithms we required to do missing value imputation in R, and ran those on their Netezza based data warehouse platform, just so that we could leverage the processing power of their MPPS system to do some of these heavy lifting computations. Now, once we had done and we knew that the entire data was prepared and ready for consumption, we implemented the weighted RFM, which is also called variable importance RFM technique, uh, in our script, because we wanted to tweak it to our requirement. We wanted it to be variable in nature, which means that we wanted this algorithm to take the inputs from the business user and accordingly on the fly modify the way it computes scores for customers. We had to use R scripts, and we couldn't take any of the out-of-box native functions available with MicroStrategy. So we created our own custom R script, and because MicroStrategy has a very strong integration capabilities with R script, in just 3 simple steps, we were able to integrate this R script as a calculated KPI within MicroStrategy using its native R packages. Package integration. So that's what we did for the core algorithm that would help us do the RFM scoring and segmentation. Once that was done and we were able to segment our customers into different 7 segments that we identified, looking at calculating the propensity to buy score, which is a very standard logistic regression algorithm that we used MicroStrategy's own advanced analytics library there to do the logistic regression without really using any custom R program. Now that's where we use MicroStrategy's inbuilt capability and inbuilt advanced analytics function. So MicroStrategy has over 350 plus advanced analytics functions right out of the box, which you could use, and that's what we used here. And then finally, the output, which was essentially a list of must-send invitees, customer IDs, their emails, and some of the other details. We presented it through a web and a mobile dashboard and report that the business user can use directly and start sending invites. Now, in addition to this, because ours was the weighted RFM technique and solution that we implemented, we wanted to give business user the flexibility to change the weightages on recency, frequency, and monetary value so that they can target the right set of customer segment they want to. For this, we leverage MicroStrategy's transactional services, through which they were able to write back and change the weightages assigned in the RFM model for it to then accordingly realign and do the scoring differently. So that's how, if you see, right from using visual insights to using the Netiza's native R integration capabilities, to using R integration capabilities of MicroStrategy, to using out-of-box MicroStrategy's advanced analytics functions, to sort of insight delivery capabilities of mobile and web, and then also advanced capabilities from MicroStrategy like transactional services. We used all of it. We used all the technology that was available to us to operationalize the solution end to end. So I'll take a pause here. So and here is what really was the solution that got delivered finally. So while and here Vimal, you could swap actually. So this is the solution, which is essentially the list of customers who need to be invited. Now this is a self-service tool because next quarter, if you're looking to target a set of geographies, you could filter the geographies. If you're targeting a certain segment like frequenters, spenders, first timers, shoppers, churners, you can filter the segments you want to target, and then within that you could filter the loyalty tier you want to target. And based on these inputs, the solution or the system will generate the list of invitees that you should invite. So this was the core solution that we offered. But with this, we also provided them this dashboard, which gave them a lot of other insights about their customer base. So since this algorithm required us to do segmentation, it required us to do customer profiling, we extended the solution to provide them a customer insights dashboard, which will tell them out of their customer base of 930,000 customers, how many are first timers, how many are frequenters, how many are the best customers, how many customers and what kind of customers are sub-zero customers, what's the average spend they have, what's the average frequency of shopping with them, and things like that. So this was an additional over and above insight and a byproduct of this whole solution that we delivered to them, for them to take a strategic view of their customer and know if they are onboarding the right set of customers that they would like to. So this was an additional added capability that we delivered to them over and above the core ask that they had from the solution. Now, if you see what were really the differentiators for us as we implemented the solution, one, right from day one, we thought and we had focus on operationalizing this whole solution on the existing BI landscape, delivering the insights through the existing BI channel. And that's really what we did, leveraging technology and our understanding of technology and how it can be leveraged for advanced analytics solution. Two, we used the weighted RFM and segmentation techniques, which were not built out, for this solution, but we had these accelerators available with us. We have a segmentation, productized segmentation accelerator that we used for faster time to value in this case. We had a 4D methodology that we used, which is where, right from day one, apart from understanding what advanced analytics algorithm and techniques to apply, we also look at what technologies to apply, how to architect those technologies, etc. And then, that's the differentiator we have with our methodology. And that's the methodology we use, the 4D methodology that we have to ensure that we are delivering a high quality solution with a faster time to value. And finally, if you look at it and you look at the dashboards that you saw just a few slides back, it's very important that you focus on data visualization, because advanced analytics outputs can sometimes be very complex. So if you deliver a standard deviation chart, or you deliver a Pareto diagram to the business user, a marketing analyst, he or she will not really understand it and be able to comprehend it, and therefore will not adopt the solution. So it's very important that you focus on how you're presenting the insights and how are you making it very, very intuitive for a typical regular business user to consume. And that's really where our data visualization expertise came handy for us to make it very intuitive and easy to consume. And that's what was one of the key differentiators we have. Now let's talk about the results. So we spoke about us having identified 278 additional must-send invitees, of which our model predicted that at least 167 will certainly make a purchase. The model also predicted that the average purchase by these identified customers would be around $6,100. But even being conservative, if we take it as $5,000, we are talking about a 835K uptick in revenue just on account of these additional must-send invitees that we've identified. Now, this customer of ours does at least 4 such events annually, and if you look at that, the whole solution has a revenue ups potential of $3.3 million if we implement it right. Now, this is just from the revenue uptake side, but there's also cost saving. Cost saving on account of automating the whole process of identifying customers, which was approximately 24 person weeks a year. So you save that much of cost, and those marketing analysts could spend that time doing something more fruitful. And also obviously the cost of hosting a sub-zero customer, a not so profitable customer, by inviting wrong set of customers to these high-end events. So there would be those cost savings as well. So a solution like this, with the focus of operationalizing it on your existing BI landscape, can really deliver a lot of business value, and that's really what this example shows.
In our environment, verify that the relevant packages are installed. Like we need to ensure that MicroStrategy our package is installed in our R environment. So in this case, it is already installed. In case if it is not installed, you do install it. So as we are having it already installed in this case, so there is no need of installing it. Now, when you are loading the MicroStrategy R package, it is giving a message that you can use the deploy functionality in this package for R script and MicroStrategy integration. So execute this function. This function will generate a dialog box. The purpose of this dialog box is to select the right script for integrating with MicroStrategy. So in this case, we are using the R script that have been developed by MicroStrategy. These R scripts actually come with R integration packs. So this R integration pack, it is located in, the location may vary depending upon your what location you specify by installing R integration pack in your local system. So in my case, it is located in program files R integration pack. So R integration pack comes with R script for some certain algorithms, like we can see here R script for ARIMA, K-means clustering, KNN and all that. So we intend to perform cluster analysis in this case. So we would be we are interested in using K-means clustering R script in this case. So from the selection dialog box, you will select the K-means clustering file. So it is getting loaded. Now this dialog box, actually after selecting the relevant R script, now we can see this dialog box is having having different sections. So what are these sections? So this first section, it is actually the section of unused variables. These variables are present in this K-means clustering R script, but they are not used. They are not being used currently. So what inputs we can see where star. So this actually indicates that the variables that we are specifying as input variables. where star actually indicate that we can specify one or more than one as variables as input variables. So where star actually indicate the multiple variables that we can pass. Now the third section is that of parameters. What are the parameters? We will see one by one. So the first parameter is exact k. So what is exact k? Exact k is actually the number, I mean the exact number of clusters that we intend to get from the data. So that is the exact k. Now next is max k. Now max k and exact k, they both correspond to the number of clusters that we intend to get. But the case is that in case if is in case if by mistake we specify exact k at 0, then algorithm will have to, what value algorithm will use to determine the number of clusters. So it will use max k in that case. So when exact k is specified incorrectly or it is not specified, let's say by mistake we specified it at 0, so max k would be used by algorithm to determine the number of clusters. Seed is actually the random number that is being used in our script. The seed actually there is need of generating random numbers for performing cluster analysis when we are using k-means clustering. So seed is used in that case. File name is the name of the file that we are using. So here in this case we are using k-means clustering.r file. Okay. So these three variables, that is exact k, max k and seed, they are having some default values. So exact k, it is having default value of 4. Max k, it is having default value of 10, and seed is having default value of 42. So in case if we forget to specify this value, then default value would be used. Now what is output? Output is actually the cluster, I mean the vector of numbers. It is a vector which contains a numerical data. So what vector is it? So let's say if I am specifying that I want 8 clusters, so this vector will contain 1, 2, 3, 4 up to 8. So it actually contains the numeric value of cluster. First cluster, second cluster. So like that, it's a vector of numbers. So output is the cluster numbers. Okay. Now in the right lower corner, you can see metric expression is getting generated. This expression is getting generated as a result of changes or modifications that we will make in this parameter or in this parameter section. Like this metric expression was generated based on the file that we selected, as we selected k-means clustering.r file. So this metric expression was generated. Then later we specified this value. Now let's say I specify here 10. So, and I am saving it. So now you can see that value has got modified here. It is 10 now. So whatever modifications I will make here, that will be reflected in this metric expression. So as we intend to make 8 clusters in this case, I am specifying 8 here. I am saving this script. So now again it is 8. Now once this metric expression is has got generated, I will select this metric expression and then I will copy it over clipboard. Okay. Now once you have copied this, save the script once again. Now it is it is good practice to have the R section closed while we are using this metric expression over MicroStrategy. So for convenience purpose, I will copy this metric expression in Notepad. I will save the script once again and then I will close it. I will close the R section. Now we will use this metric expression that was generated by deploy R in our MicroStrategy dashboard. So this is the report for DFS recency, frequency, and monetary analysis. Now we actually need to segment the members based on three variables we are considering, that is recency, frequency, and monetary. So now we will use this R metric expression here to form the clusters. Now to do that, I will create a metric. In the metric definition, I will paste that metric expression that was generated by deploy R. Now here, what is wheres? As we have seen, wheres actually indicate the multiple number of parameters that we have to pass for generating clusters. So in this case, we intend to use recency, frequency, and monetary total as the input variables for generating clusters. So once I have selected the relevant variables, I will validate the metric definition. Okay, let's say there's some issue. We'll check it. Okay, now the string metric definition has got validated. I will give it a suitable name. RFM cluster. Then I will save that metric. Now here I can see that RFM underscore cluster, this metric has got generated and it is giving me numbers ranging from 1 to 8. So now my clusters have got formed. So I can say that this membership ID this belongs to the cluster 7. So like that, for the entire data I have formed 8 clusters, and this number actually indicates to which cluster this record belongs. Like this record belongs to 7 cluster, this record belongs to the 8 cluster, and so on. So this is how that we can cluster the data using R and MicroStrategy integration. Now, few things that we need to take into consideration. What are the significant issues that we need to take into consideration in integration process? Like we executed deploy R. So when I am executing deploy, what actually is happening, that we will see. I am selecting this script. So whenever I am executing deploy, I am selecting the relevant script, analytic signature is getting generated. So what is that analytic signature? If you go to the that k-means clustering R file, we will see that the upper section of this R script is actually in the form of comments, but it is actually an analytic signature. This portion is called as analytic signature, which is generated as a result of executing deploy R and making the necessary selections. So this parameter value would be passed in that signature, and then the script would be executed. So this section is called as analytic signature, which actually plays a significant role in the integration process. So this was how we can form the clusters using R and MicroStrategy integration.